Battery warning light on in the dash of this vehicle. As you can see there, that light is illuminated. We're currently just below 1000 RPM on the dash. This is a Toyota, and one of the most common questions I get, be it from all apprentices, techs, or the customer themselves, is what can cause a charging issue on a vehicle? Can a battery do it? Is the battery at fault? Is it the alternator, or is it something else that's causing it? The short answer is any of those items can cause that issue to come on, and there's many different symptoms which can lead you to the actual solution and the fault. In this video, I'm going to be taking you through a step-by-step guide on how to successfully test and diagnose for a fault like that so you can fix it yourself. Okay, so the very first check I always do while I'm in the vehicle before I turn it off and start to check around the battery, etc., is bring the RPM up to around 2000 RPM or so and just confirm that the light doesn't go off. You can have an issue with the alternator actually exciting, and if it's a case that as soon as you bring the RPM up, the alternator light comes off, you can have charge going through the battery after that. But as you can see on this one, light stays illuminated all the time, so we're going to switch the engine off now, go under the bonnet and start to do our checks. Okay, so I'm just set up here, about to start doing some visual checks on both the battery and the alternator itself, which I am going to take you through and show. But a couple of things to consider. Symptoms that you may experience and symptoms that customers have experienced for me in the past that get mentioned at drop-off when we have these type of issues. First of all, we have the battery warning light on in this case. So that's obviously a very common symptom that you might have. A completely flat battery is another one where the alternator is not charging and it just drains down the battery completely, but we need to be able to determine if that's the battery or if it's the alternator that's causing that. Other issues, especially when driving at night, is customers see that the headlights or the low beams are dropping down, so there's dimming lights. You can also have interior lights that's dimming. I have also had experience of radios cutting off and other electrical systems shutting down as the voltage starts to drop. So the electrical system, especially on modern vehicles, are extremely sensitive to voltage. So should you have voltage dropping down lower than the range is needed to power these modules or items, they will start to shut down as you are driving. You can have stalling on the road, so if it got too low, the actual vehicle can cut out altogether, or when you turn the vehicle off, it instantly try to start it again, it will not start. There are some of the more common ones that you would experience. You can have intermittent charge issues as well. They can be a little more tricky to detect. Another symptom can be noise from the alternator. This one may have it, so I will check that in a second. It did sound a bit groany when I was in the cabin earlier on. You can have interference as well. So there can be a AC ripple issue, it's called, which there is a test you can do, and I'll also take you through that, where you can have interference in other electrical systems because of your alternator. So that's not a very well-known symptom or fault, but it definitely does exist, where you can have alternator issues causing sensor issues as well. So there's some considerations. Lastly, if you have a completely dead battery, don't rule out a parasitic draw. I have seen techs in the past see a low voltage reading on the alternator, not do a full comprehensive test on the battery and alternator, and assume that the low voltage reading was caused by the alternator, replace it, and they have the same issue again because there's a draw on the battery itself. So if you have a parasitic draw, vehicle is left overnight for a long period of time, let's say one of the modules is staying on and is pulling down too many millivolts out of the battery overnight, you can come out and it's a dead battery. You don't want to assume necessarily it's the battery or it's because it's not getting enough charge. Again, very less likely, but something to consider when you're doing these types of diagnoses. Okay, so the first checks I always do is on the battery and on the alternator itself. This is something that can get overlooked if you're trying to move too fast, and you can easily make a mistake. So always remember that the alternator is a mechanical input. So without this pulley down here spinning, having a drive belt and spinning freely, so just down there, you're not going to be able to create charge voltage that you need. So AC gets converted into DC, and without that mechanical input off the pulley, that's not going to happen. So drive belt intact, no tension loss on the belt. Pulley itself, there is what's called overrunning pulleys as well, which are a one-way clutch. You can have an issue if you have a pulley that's not functioning right. You can have low charge. You can also have them spinning. I've seen them actually detach off the threaded outer part altogether. So some considerations immediately is just checking that. So when you run it up, you have full tension and no issues, which in this case is absolutely fine. Tension on the belt is fine. That pulley is spinning like it should, and no issues there. The other one is, if you have a visual, now alternators can be in bad positions, but if you have a visual on it, this is the B post, so this is B plus, and this runs to the battery direct, but you want to make sure that you actually have good connections, that the alternator and connectors are all intact, and that you don't have a loose connection there. If you have loose connections, it will also cause voltage issues. Then on the battery itself, when we go over here, we want to check the battery terminals. We also want to check the clamps to make sure that they're not loose, no corrosion present, and that the ground wire is good, and that the positive wire going down is also good. Now, if your battery is in the boot, some of these tests are going to be a bit more difficult, but you will have clamping areas. So there'll be a chassis ground somewhere that you'll be able to use, and then you will have a jumping positive connector that you can also use to do these tests. If you look here, this battery looks like it's a new battery, which is probably the first thing that was done when they seen the battery light on. It's not the first time it would be misdiagnosed. You can do a test on a battery, have a failure, and then they just replace the battery and see. So we're going to be using the multimeter next, and we're going to be doing some simple checks. You can also do these basic simple checks by just using a multimeter, and then we're going to be going on to more complex checks with the likes of an oscilloscope later on. But the first checks I'm going to do is with the multimeter. Also check that the electrical connector going to the alternator is secured, that there's no wiggle on it, nice and tight, and that there's no wire issues. So if you have any fraying or any damage, I've seen in the past where this runs across parts of the body and has actually rubbed through. So just having a quick look visual wise wires before you move on. What are all the possible causes that gives you a no charge issue like you have in this vehicle? So of course we have the battery and we have the alternator, we have the terminals, we have the clamps. Any issues there can cause that. Also the drive belt, the tension on the belt, that pulley, any mechanical issue on that side of the vehicle can also cause it. The wiring, any of the wiring going from the ground or the positive all the way through, if you have an issue connection wise on any of those, no matter where it is, it can cause that issue as well. Fuse relay, or in some vehicles that are controlled by the ECU, you can have an issue there, whether it's grounded by the ECU, etc. That can also be a reason that you're having an alternator issue. Now, having the oscilloscope hooked up, I was able to see quickly that the signal was not correct. It was coming in and coming out. The waveform was erratic, which gives me an indication that this could be a connection issue of some sort. Doing a wiggling test on the wiring is something I utilize all of the time when I'm doing these types of checks. It can give you an indication as to if there's a break in the wire, if there's a connection issue, if there is maybe a bad earth, by catching and pulling on different wires and harnesses and junction connectors to see if you can see any difference in the waveform as you're doing it. With this one, up at the battery on that big block connector going to the positive and the wiring harness and loom that comes from there, I was able to see that the waveform was dropping in and dropping out at that particular junction. Now with that information and the visibility down at the wiring harnesses, I could see that this had been worked on previously. There was connectors that were broken, which secures the wiring. So there are the symptoms and the causes that you can experience. Now let's get on to the testing. Okay, I'm just setting up my tests now. Again, before I start the vehicle, I want to do a couple of quick checks. We always want to check the battery resting rate to see what that is, because we have a comparison when it started, whether the voltage jumps up and how much it jumps up. If you haven't used a multimeter before, what you will need to set it to is this one. This is volts DC, which is the lines across, which is direct. That is alternating current, so you want to set it to there. Depending on your range, if you have a multimeter that has 20 volts, 60 volts, etc., you want to set it to the nearest. It's a 12 volt battery, so you would set it to 20 in that instance, but we have ours set up to voltage there. Now, expected results, that is something, I'll turn that on in a second, that is something that in the motor industry can vary depending on the type of vehicle you have, and there's always considerations as well. So what I learned as a general rule of thumb with a multimeter check on a battery when I was going to college was a bad battery is 12, less than 12 up to 12.2. Okay, now the considerations therefore on that is it could be a good battery, but the charge in the battery could be low and it may just need to be recharged and rechecked. That's why there is limitations on a multimeter check like this. It's always better to actually have a battery tester when doing an initial battery check. But if we had a charged up battery, let's say, and we done a resting charge rate check with our multimeter, 12.2 and below is what I deem not good. 12.3 to 12.4 is okay, and then a good battery be 12.5 and above. Now, I have seen batteries resting on our shelf at work being the 12.3 to 12.4 range, and they're perfect batteries. They just haven't had any charge go into them for a while. So again, considerations depending on how long the battery has set for. The next thing is expected results on the alternator. Again, a general rule of thumb that I was advised is 13.6 to, let's say, 15.1. Now again, that isn't necessarily the case anymore with all vehicles. You have battery management systems, you have smart charging, you have sensors across poles on that side that is monitoring the current going in, and you have ECU controlled operation on that system dependent on. It doesn't have constant current going through it. It's being switched on and off duty cycle based. So you can have a result that's lower than that, and you can have a result that's higher than that. And not to dwell on that, just know that different systems can have different charge rates, and just know what type you're working on. Is it a stop-start system? Does it have that clamp around the leads? If it does, consider the charge rates can vary on that. If you're wondering about why that is the case with those alternators, it's due to the variable voltage. They're variable voltage alternators, which means that they can be a low resistance with a high capacity capacitor, and capacitors can charge and discharge large amount of electricity quickly, and there's benefits to that for manufacturers with reduced fuel economy and emissions, because the higher the amount of load that's on the engine, the less efficient it becomes. So if you have a lower load on it, therefore, in theory, you can have a better fuel economy and better power output. Let's talk about charge as well. So the charge is also dependent on the battery condition and the battery charge. So consider that when you're doing the tests. Also the load that's on. So when you're doing a test, when it's running, the load that you have on the system will also vary the results that you're getting. So if you have your radiator fans running all the time, if your blower motor's on, AC is running, lights are all on, radio's on, you basically have your electrical system loaded up to full capacity, then you're going to have a different reading on what you're getting on your output. Temperature also plays a role, and they're all considerations to factor in when you're doing these tests. I have a demonstration set up here now to showcase the exact correlation between load on the electrical system in relation to the alternator charge rate. So right now we have 14.19 at idle, amps coming through. In the amp clamp I've set up is 11. I'm going to turn on the headlights, turn on the air conditioning, turn on the radio. You're going to see this reading drop down and then come back up again and stabilize, while you see that amps increase with the system being loaded. Okay, so you can see 62.5 coming through up there, 13.8, and you could see that drop down and spike up. Now I'm going to turn it off again and you'll see it restabilize. And there you go, we're back up to 14.1 and down to a lower idle rating on the amps. And that's just a demonstration to showcase how, depending on how much items you have on your electrical system, how much work is being done. Okay, so we're all set up to do our checks now. I actually have an amp clamp on down there, which I'll show some readings of in a bit. But we have our multimeter, it's on DC, and we're going to be doing our checks. First of all, we want the voltage. So we want to see what's in this battery now, which is 12.58. That's really good. One thing you can do is change the location of your lead on to different areas of the wiring, on the clamp, on the post, and see if you still get readings. So if you have insulation, a protectant on this, you need to make sure that it's cleaned off and that you get a good reading. And 12.58, and you can do that along in the different areas, so I can do it from there to there as well. And if you're not getting a good reading, make sure that you're checking on the connection, and as you can see there's 12.58, so you can check that all the way along that way. The other very well known is voltage drop. So using the two same leads on the same terminal, so negative to negative, will be going across. So we're checking voltage drop from the battery terminal across the clamp, and you want to be ideally seeing little or nothing there. It should be pretty much zero, which it is. And then same on this side, and again the contact is the main thing. You want to be nice and clear. Any concerns, sand it off, get a scraper, make sure you have good connection. So that's the battery. We have the voltage reading now. Before we start the engine, we're also going to do a quick check from the alternator. So I'll move this over. Now we're going to be doing some checks on the ground, which is the case in itself of the alternator. This battery positive, so this is B plus. I have pulled this back, which is the cover, and you can also do some voltage drop checks at the electrical connector itself. You'd have to identify which wire is which, but you could check for voltage drop. You can also check for voltage presence and all that down there too. But for this, we're just going to be checking on that one and the body. Okay, so you can see the multimeter is reading 0. We're going to be going across the post first of all, so that's negative on the battery, and we're going to be going positive here. and we have 12.58 again, which is good. We're going to reverse that. We're going to go into the casing. I'm just jamming that in, and I'm going to just move the terminal on the battery to the positive. And again, we get 12.58, which is a good result. Now we're going to do the voltage drop across the same. So it's set up to the negative. Ignore the minus, that's just reverse polarity. It doesn't matter. So negative on this side, we're going to be going to the negative battery. And again, we should be seeing no voltage drop, which is correct. I'm going to be going to the positive now on the terminal over here, and the positive down here. And again, we have no voltage drop. So we have confirmed that we have no voltage drop across each of those. We know the battery charge, and now start the engine, check the alternator charge rate, and show you the amperage that's coming through, so the current that's coming through on that as well. Okay, for this one to help out, I'm just using one of my clamps. These are extremely effective, using alligator clamps and being able to use your leads through them is very good. Also, you can get extender cables if you have a battery in a different area that you need to use. I'm going to set up my amp clamp here. This is a small one, so this is only up to 100 amps. But we'll be able to check at idle the amount that should be going through it, no problem. So we set this up to, see, it's got alternating and, let me zoom in on that, it's got alternating and DC. So we want to make sure the range, see it's on AC, so we select and we're down to DC. Then you 0. And in this case, I'm just putting it around the negative because the positive is too hard to get. But again, it won't matter because it's a complete circuit, and we're just confirming that we have amperage coming through it. So I don't know if I can set that up to see. Let me get a rag. So I'll just prop that with a rag. So you should be able to see it there. Okay, so now we can see the amps that's be coming through, and we also can see the charge. So again, we should know the expected readings of that. This will vary dependent on make and model and the amount of load that's on to how much is running through it. But I'm not going to have any of the electrical system turned on. The lights are going to be off. I'm going to run it and see if we have anything coming through and if we have charge. Okay, so we have 13 amps that's going through there, and we have 12.13. So instead of the voltage going up and the alternator pumping through current, we have it going down. So we have the opposite. So we're not getting a charge through on this. Now we can move these leads into different areas to check if we have any voltage present anywhere. We can go directly over to the alternator to see if it's outputting anything. But ultimately, right now, we have a bad reading, which means the alternator is not charging. And what I'm going to do now, so you can see potential difference, is I'm going to turn on the lights. I'm also going to turn on the fan, and you can have a look at the amps that's coming through and also the voltage, what happens there. So we have a massive drop to 11.6, and you can see here we're now up to 48 amps that's coming through. So they are the amount of draw that's coming out, and you can imagine what effect that would have on a battery that's not charging and how quickly that would pull it down to a state that it wouldn't be able to start or run again. Okay, so the next checks I'm going to do is a voltage drop check. We're going to go on the positive here. So I have my clamp down again, go down in there. I'm going to go on to the negative of the battery just to confirm we have a good connection on that positive, which we have. Then I'm going to go on to the positive terminal, and we have a voltage drop of 0.02, so beautiful, within spec. The next, I'm going to jam it into the casing. Always good to confirm you have a connection by putting it onto the positive, and again we have that voltage. That negative is just saying it's reverse polarity again, which is all good. Now we're going to do the voltage drop check, negative to negative, and we have 0, which is perfect. That's what would be expected on the negative side. Okay, so the next check we're going to do is a simple battery test. This is a battery tester that can check all these different types. So whether it's a start-stop battery, that AGM, or a regular type battery, this will be able to check it. Now, one thing I would always urge consideration of is the fact that this was drained excessively for long periods while the customer was driving to get here and while we're testing it. So this is going to be drawn down in charge. That can be reflected in the test. I have seen these to fail good batteries when the alternator has drawn it down too much. So depending on the state of health and state of charge, we can make our own assessment, but I would be likely always recommending to charge the battery and retest later. So we're going to put it on there. Start stop, it's not start stop, it's just a battery test we're doing. It's a regular flood type. If you were going through AGM flat plate, so you have the different options. Zoom in on that, SAE, and it is 550. So click on that, and it's saying bad and replace. It's showing 12.48, so we've brought down the voltage. When we started checking this, it was 12.6 originally. It's now 3.81 it's rated at, but let's have a look. State of health 69%, which is on the low side to be fair, and then 85% state of charge. But when this alternator be charging right and the battery is at full capacity, I would expect these results to change greatly. So I wouldn't condemn that battery based on those readings. What I'll do is rectify the alternator issue and then recheck this battery afterwards. So I'm going to rev the engine now up to 2000 RPM so you can actually see what's going on there.
And what you can see on the reading is 0 from the output of the alternator going to the battery. There is no amp reading at all. I get into the vehicle and then I rev it up to see if we can get any difference or any reading come through. And as you could see, there was absolutely no change. Now the next part of this was meant to be a step-by-step guided instruction on how you do an alternator AC ripple test using a picoscope predominantly in this one, but I also showcased a multimeter and an amp clamp and the expected results you would get for good and bad, and basically gave you an overall picture of it. What I decided to do was remove it from this video because it was actually doubling the size of this and it was making the video over an hour long, which is way too long. If the interest is there, I can absolutely make another video showcasing all of those in detail and put that up on another stage. Just post down in the comment section below and I will put it on the to-do list. What I will say before I move on from the AC ripple test is it's definitely something you should have in your arsenal if you are diagnosing vehicles or you plan on getting into diagnosing vehicles. The electrical system on vehicles are very sensitive. Having the diodes fail in the alternator and that AC being introduced into the DC system can cause all sorts of issues with sensors flagging faults, with signals being interrupted, and therefore once you have that and you know it could be a possibility, you can do those quick checks and analyze it.
Just want to showcase a couple of other tools that you might use when testing. This is a power probe. This is a Power Pro 3. On the display, after you have it clamped up, you can do quick checks. Fuses, which I'll show in a second, is one. But if we're doing an alternator check, which I've done many times, go down here, 12.4. So you're getting straight away a reading that's a positive. Shows the positive symbol, and then you can see a ground. So you're able to do that quick check. Another thing is if you disconnect the electrical connector, power there, ground there, and then you can check them with the ignition on and running, etc. You can back probe in there, but it's very handy and useful. The other one is when you come up here, fuse box. So fuse box, alternator is there, 7.5 amp, and down here is a big alternator fuse. So if we look here, that would be the fuse that we're concerned with on possibly the sensing side, and then we have here is the alternator 120 amp, and if you look in there you can get a visual on the condition of them. So if I zoom in on this side, you can see it's intact. That's the main big fuse that you would address if you had an alternator issue. It's all good on this one, and that is good. So with this, you check across it, and that confirms that that's a good fuse, because we have both sides positive when we checked it. The other one is a test light. The reason why I don't really use test lights in this setting is you can't get the voltage reading. So that's why I'd always go to, now you do load it, the circuit. This is an incandescent globe that's in this. So there is that plus to it. And it's a very, very useful tool for checking things, but I tend to go for my power probe a lot when I'm doing checks like this. But down here, it's on a ground on that side, and then we go to a positive, so we can see there it's lighting. Then if we switch it, we put this onto the positive, then we'll check and we can confirm we have a ground coming through there. So using your light, you can do checks, power probe, you can do checks, oscilloscope, multimeter, amp clamp. You can cover a wide band, and there's loads of equipment in this game to do similar jobs. But now that we have all of those checks, it's simply on to replacing the alternator, and I'll come back and show you the results at the end. Alternator is now out, it's on the bench. A lot had to be removed to gain access to get the alternator out of the way. I've got the alternator out now. This is the old one here, the new one obviously there. Just want to show you this. So this comes in the box of the new one. So test report passed, it's 130 amp, and then it gives you a breakdown. So alternator maximum output 158, the power output 1831 watts, voltage set point 1396, leakage current 0.48, ripple current is 6 amps, and then you have the alternator turn on speed, so the exciter is 570, so that's when it actually starts to kick in and work. We have down here the output current table of this alternator. So if you look at the different ranges that it comes up, and right here we have the different amps, the amperage that it outputs, and the RPM table. So big incline straight away, and at around 2.5 it starts to taper off and become less. So at 2.5 we have what, 140 is it? See, 2.4 we have 140, and then going all the way up to 158, which is at 6,000 RPM, and 156 at 5,000. So this is the ripple output pattern that you would expect. So that's the ripple pattern, a nice consistent waveform with not much difference between the peaks, the high and the low. Test wise on this, if you've never done one, these do also have a one-way clutch. We can check inside of the alternator if we wanted to do some testing, but I'll just show you the one-way clutch test on this. So in here we have a rectifier. This is the overrunning pulley. Through the center you have a bearing, then you're going to have the rotor, and then you're going to have the stator that it is into. Then you have the regulator as well. So they're the components that make this up. Okay, test wise, small screwdriver, put it down and you put it into the fan itself. And can you hear that squeak? So it is moving freely in one direction, but it is restricted. That should be much freer than that. And it does lock on the other side, but very noisy. Versus the new one. Screwdriver in. Nice and free. Like, this is a tiny screwdriver, so you can imagine what little resistance there is to actually turn that. Then the other way, just lock it and it's tight. So we have a nice free pulley on that one and a new one, and that's about to go in now. So the alternator is back in now. Everything is pretty much back on except a few plastic pieces, and we're going to run through our final checks to make sure this is all good. Belt is on. We also want to confirm that we don't have any leaks from anything that we disconnected. And currently voltage 2.49. I have it hooked up here to the battery, and we're going to give this a crank. So battery light gone off straight away. And we now have good alternator charge going into the battery. I'm going to do some initial run-up checks and visual inspections on this, and then afterwards I'm going to go back on and I'll do my final checks and walkthrough with you to show some after results with the working alternator. This is on the AC setting, so we've 2.3 coming through on that AC side. If you were checking for ripple with the amp clamp, I'm going to check output now on the DC 18, and I want to put on the accessories, put on the fan, headlights, and just see how much this goes up to. We got 47.7 right at the alternator at the moment. I'm going to take this off here.
And with the old alternator on the bench, I decided I'd take off the cap of the overrunning pulley and do an inspection. And in the earlier clip you could hear that this was making a lot of noise, so I was interested to see behind this cap. And if you're wondering about repairs on alternators, it's pretty much become a thing of the past in workshops due to multi-factors. One of those factors being the time consumption in testing. The second is the time off the road for the customer, the cost of the parts, the itemized list of them, how advanced the alternators have become, and then the readily available alternators at quite a reduced rate from what they used to be. When you put that all together, it's just better overall for the customer to replace it.
Just after coming back off the road test, we're up to operating temperature. It's been running for a long period of time. No coolant leaks, alternator running like it should, and battery warning light of course off on the dash. I really try to include as much information as possible in relation to the testing process of the alternator, give you some different tests and information that you might not have seen before, using some basic tools and using some more high-level tools. So whether you're a technician trying to get a bit more diagnostic in your arsenal, I hope you can pull some information from this video. I really hope you enjoyed this one. Hope you found it useful and informative. If you did, please like, share, comment and subscribe, and I hope to see you in the next one. Thanks for watching.